All right, hello ATM. This is going to be a video on 410, the class portion. If you want to follow along in the textbook, we are on page 591. I realized that in the last couple of videos I haven't mentioned the page number, so sorry about that. Today's lesson is all about the quadratic formula. So even if you feel like you know how to handle the quadratic formula, please watch the whole video because there might be a detail that you have forgotten. So in this paragraph, they're talking about a baseball being hit, and it says we can approximate the flight of this ball with this equation. The input x represents the number of horizontal feet from where the ball was hit, while the output f of x, which is also y, is the height of the ball above the ground. Okay. In order to find the total distance the ball was hit, we need to find the horizontal distance that corresponds to a height of 0 feet. So let me explain that a little bit. I drew a picture down here at the bottom, or underneath the paragraph, of a ball being hit either from a bat or if they're throwing the ball, they're talking about a home run, so I'm assuming from a bat, and it's being tossed up in the air, and then we're assuming it lands on the ground at a height of 0 feet, okay? So that means that the height, which is y, would be 0. So they're changing f of x to 0, okay? And if you're looking at this equation, we know how to solve an equation like that. We did it in the last section for 9 with factoring, but we don't know how to factor something with decimals, okay? And to be honest, you guys, if the numbers are really small or really big, I wouldn't use factoring even if it could be factored because it's probably really ugly. So instead we use the quadratic formula. So here is the quadratic formula. The textbook writes it out twice because there's a plus or minus, but I would just write it out once. Okay, so that's why I circled this here for you. I also wrote steps off to the side. Please do not plug all the numbers in all at once. It's kind of a disaster and it really gets messy. First, calculate what's called the discriminant first, b squared minus 4ac. Figure out what goes underneath the square root in step 1. That should be a single number, okay? Then you can go to the formula, and usually we get 2 answers in word problems. Sometimes we get 1, sometimes we get no solution, but usually we get 2 answers. And in word problems, we have to decide which answer we want to keep and which answer we might want to throw away, okay? All right, so for the equation describing the home run, I rewrote the formula that they gave us. What numbers correspond to a, b, and c in the quadratic formula? The a value is in front of the x squared, so I wrote that down. The b value is in front of the x, so I wrote that down. And the c is the 2.5 at the end, so that goes at the very end, okay? All right, so moving on to number 2, they actually want us to calculate the quadratic formula, okay? So I rewrote the a, b, and c for us at the very top. And remember, steps, we're going to do the b squared minus 4ac first. So we have b, so 0.718 squared minus 4 times a times c. And I'll put this in the calculator all at once. 0.718 squared minus 4 times negative 0.00146 times 2.5, oops, missed my parenthesis, times 2.5, and I get 0.530124. Don't round that too much. If you round it right away, it could affect your final answer in the end. So try not to round that if you can. Now we go to the bigger formula. So using the formula that you hopefully wrote down, we have x equals negative b comes first, so negative 0.718, plus or minus the square root of the number we just found, all over 2 times the a value. Okay. Now, you'll notice I have purple parentheses written here. That's because when you go to type it in the calculator, you need to tell the calculator, do everything on top first, then do everything on the bottom, and then divide. Okay, so make sure you're using the parentheses. Now, when I go to put this in the calculator, you cannot do plus or minus at the same time. So you're going to have to do it once with plus, and then go back and change the plus to a minus. So I'm going to lift my calculator here so that's in focus. Start by opening the parentheses. Negative 0.718 plus the square root 0.530124. If you have one of those calculators that stays in the square root, make sure you press your right arrow key to get out of the square root. If you have a calculator that opens a parenthesis for you in the square root, make sure you close it now, but then also close the one that we started. So if you have one of those calculators, you'll have two parentheses here at the end. Now divide, open another parenthesis, and do 2 times negative 0.00146, close parentheses, and that's one of our answers. So I like to do two different arrows here because we get two answers, so negative 3.5. It says round to 1 decimal place. Now I'm going to go back. I'm going to do second, enter, an arrow over to the left, and change that plus to a minus. And there's the other answer, 495.2. Okay, now these are in terms of feet. On the very first slide, they talked about X being in terms of feet, okay? Now, number 3, it says one of the solutions provides the length of the home run. What is it? Okay, well, if you look back at my picture that I drew here, this is going to be the 495. The negative 3 is going to be back behind the y-axis, okay? So the actual distance of the ball is going to be the 495.2 feet, okay? What is the significance of the other solution in the physical situation? Well, a ball can't go backwards in distance, right? So it has no significance because the ball didn't go backwards. So I already filled in that answer for us nice and quick. All right, let's move on to number 5. Now they take the formula and they write it separately for a good reason. You'll see why in just a couple minutes. But they split it up, okay? And then they take this and they say, let's just call it some number. They do it over here for the negative version as well. Okay, so this is plus, this is minus, this is plus, this is minus. So they're making us realize that this negative b over 2a is actually a really important number. Okay, this allows us to see that the value negative b over 2a is exactly halfway between the two solutions. Okay, so now it says, what's the connection between the solutions of the equation that we just found on the home run problem versus the x-intercepts of the graph that we were looking at in section 4.9? Actually, they're the same thing. So I already wrote it in for us. The solutions to the equation are the x-coordinates of the x-intercepts. They are the same. Okay, so what we were doing in 4.9 using factoring and graphing is exactly the same thing as what we were just doing with the quadratic formula. It's just different ways of finding the same answers, okay? The point where a parabola changes direction is called the vertex of the parabola. So I drew a picture here. How do we know that the vertex has to be halfway between the x-intercepts? Well, because a parabola is symmetric. This distance here should be the same as this distance over here, okay? It should be symmetric, and so the vertex is always going to be halfway, okay? Parabolas are always symmetrical. All right, now that formula that we talked about, that is actually the formula to help us find the vertex. So make sure you write that down as well. It's very simple, negative b over 2a. I usually put the negative here with the b, like that instead. That's usually where I keep the negative, just to keep it a little simple. All right, so last couple problems here. It says use the vertex formula to find the first coordinate of the vertex for the function describing Stanton's home run. So we're going to find negative b over 2a. So negative b would be negative 0.718. That's the b value, divided by 2 times my a value over here. Okay, so let's type that in the calculator. Negative 0.718 divided by, now I'm going to open parentheses so that everything is divided appropriately. Let me just double check that I typed that in right. Yep. So I have 245 it doesn't say anything about rounding, so we'll just say 89, okay? That's the X value of the vertex, okay? It could be drawn in if you wanted to. I drew a little picture off to the side over here, but this is the X value in terms of the horizontal distance right there, okay? So what does your answer describe about the home run? We can specifically say that it's the horizontal distance, okay? So this is the horizontal distance of the ball at the highest height. Okay, so this right here, this point is 245.89. Okay, that's the X value there. Now it says evaluate f of x for the input you found in question 7. That is the X value. Now they're basically saying find the Y. Okay, what does it tell you about the home run home run? So we're going to go into f of x and we're going to actually plug in the 245.89. Okay, so lots of writing here, negative 0.00146, put in the 245.89 squared plus 0.718 times 245.89. I'm running into my diagram here. Oof, there we go. And now we want to calculate that. That's going to give us the actual Y value, how high it went. So type this in. Okay, and that gives me 90.77, and again, we're in terms of feet, okay? All right, so that's the actual vertical height. I'm gonna put a little X here and a little Y there. That's the actual vertical height, so right there would be 90.77 feet, okay? So what does it tell you about the home run? The highest the ball reached is 90.77 feet. Okay. All right. Hopefully that helps you understand a little bit more about quadratics and quadratic formula, being able to use that. And hopefully you see the connection between graphing and factoring as well as using the quadratic formula. If you have any questions, comment in Google Classroom or email me, and I'll be sure to get back to you quickly. Thanks for watching, and I'll see you guys next time. Bye.